Okay, thank you. As was said, my name is Bart Szulc. This is my Twitter handle. I'm not going to talk about myself because I don't have that much time, and I really have a lot of slides to go through. Basically, I'm going to talk about a technique that we recently adopted in my company called test impact analysis. This presentation will be about automated tests, will be about test coverage, and also will be about CI/CD. So hope you will enjoy it. But first, here is the slide, the mythical test automation pyramid. I had to put it here because this is another presentation about test automation. So why not start it with test automation pyramid? The thing is that we have test automation pyramid. If you look at our tests, automated tests, we have a pyramid when it comes to quantity or number of different tests. The problem is that we are experiencing really big troubles, and that pyramid causing us a lot of pain. And you could imagine that this shouldn't be a case, right? Like every time you hear about test automation pyramid, people are telling you that if you have it, you don't have a problem. If you don't have it, then you have a problem. But I will argue that even if you reach the pyramid, you still will have problems, and you will somehow need to resolve them. And test impact analysis is definitely one of the techniques that could help you. Okay, so to give you a bit about the context, what kind of problem I was trying to solve, and I'm not going to talk in first person because this was a team initiative and I was part of the team. So I will talk about me, we, etc. So we were trying to solve big problem, and here it is. Here is the context. So as I said, we have test automation pyramid. We have those three major types of automated tests in our code base. At the bottom we have unit tests, we have a layer of integration tests, and at the top we have system tests. And when it comes to numbers, you definitely see that here is the pyramid, right? We have 60,000 unit tests, around 10,000 integration tests, and 1,500 system tests, right? So everything should work, everything should be just fine. But if you look at the pyramid from a different perspective, in a moment, from the perspective of how long it takes to execute every single test and every single type of test that we have, you will notice that there is a big difference between running single system test and running single integration test. On this chart, unit test execution time is not even visible, but it's there. But still, the difference between unit test execution time and integration test execution time is so huge that it's just lost on the big picture. And this is basically causing that the automation pyramid that you have and that we used to have when it comes to numbers of tests is really a con when it comes to execution time, because we are spending only 30 or so minutes running all unit tests, and we have tens of thousands of those, and we spend more time running integration tests, and we spend even more and more time running system tests. And when it comes to real numbers, as I said, it's 30 minutes for unit tests, but it's 600 minutes for integration tests and 2 times that much for system tests. So that's just a lot of time, and this is causing the pain. So you know how our structure of automated tests look like, right? How many of different types of tests we have, how much time we need to execute all of them. How does the development process look like? We have continuous testing, so every time something is being merged to master, to the main branch in our code base, we run all the tests, all the types of tests. So we run unit, integration, and system tests. Of course, we don't run them in a sequence. Instead, we just parallelize them, because if we run them in a sequence, we would need 2,000 minutes to run all the tests for every single change. So instead, we are parallelizing them, running every single type in parallel. And this helps us save 700 minutes, because now we are limited only to system tests, because they take 1,300 minutes to run, right? So this is the type of test that takes the most to run. And of course, you probably would suggest that we can easily reduce the time needed to run all the tests by introducing batching, right? So split the system tests into multiple batches and run those batches at once. And we are also doing that. Like we run 40 batches of system tests, but still we need 45 minutes to run all the tests, even if we batch, right? And there is a limit to how much we can batch. Like 30 is definitely the maximum number that we can reach. So still, 45 minutes may seem not that much, but in our case is, because we work in continuous deployment model, so we really try to push our changes to production as soon as possible, and 45 minutes to do something in our pipeline is just simply too much. Like 45 minutes for developer to wait for feedback whether his change broke something or is okay is just too much, and people just basically are not caring anymore about it. So we were trying to solve this problem, how we can reduce the time that is needed to execute all the tests that we have. There is one more layer of this problem, because what I saw you is just the main line, like the master branch. But we work in feature branching. This means that every time developer wants to change something in our code base, they need to create a feature branch. So they basically need to diverge from the main line, create their own feature branch and make changes on that branch. And when they are happy and ready to merge their changes to the main line, they basically merge them, right? And then we run all the tests. But also, whenever they make changes in their feature branch, we also run all the tests. So every time they make a change in their local branch, they push this change to a remote repository, we spawn all the nodes and run all the tests, just to give developer early feedback. Like, you are making changes on branches, but we want to run all the tests even though you haven't had merged your changes yet, because we care about you getting feedback very, very early. And this just adds up, right? So it's no longer 45 minutes for a single merge to master. It's also all the time spent running tests for every single change on a feature branch. And not only this, this is a waste in terms of money, in terms of time, but also it's a waste in terms of money, right? Because we need place to run all the tests. Like, we need to spawn EC2 instances. We need to deploy application there. We need to run the tests, and this costs a lot of money. And to even add to that, this is just a situation where you have a single feature branch, right? So you have one developer making a change, creating feature branch, pushing changes to that feature branch, tests run, then they merge their feature branch to the main line, also tests run, and this is how it looks like. But what if you have multiple people working on the same code base? What if you have like 100 developers working on the same code base? And this is the case in the project that I'm working on. We have something developers. I mean, the number changes. Working on the same code base and basically working in the same model. Like, every time they want to change something, they need to create feature branch. The tests need to run on their feature branch, etc. And what does it mean, like, in real numbers? It means that every day 70 pull requests are created. So this means that every day there were at least 70 feature branches available in the pipeline, and on those 70 feature branches, people were committing changes and tests were running on those feature branches. So that's like a lot of test execution. And when it comes to like the number, it's 15,000 test batches, not even tests run, but batches of tests that need to be run every single day. So that's a lot of execution. That's a lot of those 45 minutes added up and money that need to be spent on running those tests. So yeah, so what we can do about the pyramid, like how we can change it to reduce the time needed to run all the tests, and also reduce like the cost of running those tests. Yeah, you could probably suggest that we should like even make the pyramid smaller, right? So don't have that many system tests. Clearly, the ratio is still not right? Like, you should have more unit tests and get rid of the system tests, or replace them with some other types of tests. And we are in the process of doing that, we recognize that it's not good enough to have more unit tests than other types of tests. We also need to basically reduce the number of high-level tests to the minimum and introduce some other types of tests that will help us achieve same coverage. So we are introducing something that is called component test, and also we have DB unit tests. And what are those? DB unit tests are basically helping you to test your code, your Java code, because we work in Java, the application is in Java. Basically the layer that is transforming your Java code into SQL queries, right? So this is where DB unit tests are really useful, because they help you confirm that what you implemented in Java really works as you expect in SQL. And also when it comes to component, those are like smart and small integration tests. Instead of running all the tests against like fully built application, we are splitting the application into multiple components, like basically collection of classes that work together and probably also talk to database. And we run those tests on those small components rather than the whole application. And this also helps us save time, because we don't need to spawn the whole application. We just need to spawn like multiple classes, wire them up so they talk to each other, and probably also spawn database so they talk to the database. But we are in the process of doing that, and it will take time for us to reach numbers that we currently have for system and integration tests. Like at the moment, we only have 5,000 DB unit tests and around 500 component tests. So the question now is like, what we can do now, like with like limited time that we have, to ease the pain and reduce the time. And yeah, and this is basically what test impact analysis can help you achieve, right? And here is my journey, like how we even got to the place when we started experimenting with test impact analysis and what test impact analysis really is. So at the moment where like developers were struggling with running all the tests and waiting for feedback, I was doing something different. Like I was researching. I was looking into test coverage that we have. And if you were on a presentation on some other conferences of mine, I was talking about this research that I did. I basically took the numbers from our existing code base and our existing tests and tried to understand what the numbers tell me. Like if the code coverage is 80% for our application, does it mean it's good enough, or does it mean that we still miss some tests? And when I was doing that, I was basically generating code coverage reports. I was looking into usage of classes, usage of methods. I was looking into how often different features in our application are used, how those features map to code, and also looked into like historical data, like how often we change parts of application. And as part of that, I had to generate code coverage reports, right? Because I had to know what is the percentage of code covered and what parts of code, like what classes and methods in our code base are covered. And I was doing the code coverage report with Clover. If you never heard about Clover, it's a tool that helps you generate code coverage for Java and Groovy code. It's now free. It used to be it used to be the case that you had to buy a license, but now it's free, so you can just use it in your project, and it will generate you HTML report that basically first of all will tell you what is the number, like the test coverage, but also will give you like extra details, like for instance what tests go through particular code or even through particular line of code. So you can click on a line of code and see all the tests that go through that particular line. And this is not limited only to unit tests. It works also for other types of tests, like integration system tests, your WebDriver test, for instance. So when I had this report, I was able to scrape it and put it into database. So I had like a map of tests to production code. I knew what tests execute what production code, like call what production code. And that at the end was very useful for optimizing our test runs. Because if you have such database, you can now ask, why not use it? Like, why not just simply run tests for the changes, and only the relevant tests for the changes, not all of them. Because we know that every single change is basically like every single commit that you merge into a branch is just a collection of files changed, right? Like whether those files were already there and you just updated them, or there are new files, or you remove something, right? So we know that this is as simple as that. So if you now have a database that tells you, okay, you have this file, this class, and this file and this class is covered by those tests, why not simply run an SQL on that database, so it gives you only the tests that you need to run for given change, right? And simple as that. And this is what we're trying to achieve. Let's build a database. Let's make it more or less up to date, and ask that database what tests need to be run for every single change. And this is basically the main concept of test impact analysis. The problem is that it took a lot of time to generate such database. Like it took Clover a lot of time to instrument all the code that we have. Like we have around 2 million lines of code. We have like a lot of tests that need to be run in order to generate the database. So it wasn't feasible for us to build that database and make it up to date. Yeah, and basically we decided to like not do that. But still, like the idea was kind of interesting. So we started looking into other tools. And the most used tool for generating code coverage in Java is probably Jacoco. So if you haven't worked with Jacoco, it's very easy to set up. Probably even easier than Clover. You just need to add Jacoco as a dependency to your project, and if you are using Maven, just put Jacoco plugin in the plugins section, and it will generate also HTML report for you. Why we didn't choose, or why I didn't choose Jacoco in the first place for generating HTML, for generating code coverage report? Because I knew that by default, Jacoco won't give you this kind of level of detail. It won't tell you what tests go through particular line of code or what tests cover particular class. It will tell you like more or less what is the number of what is the coverage percentage for package, class, etc. But won't tell you what exactly is covering this class or this package, what tests. But if you look into documentation of Jacoco, that wasn't true. Like this was my understanding before I looked into documentation. Because if you look into the documentation of Jacoco, you will learn that Jacoco works as a Java agent. So if you have your application and it's running, right? Jacoco simply connects to that application and waits for the application to do something, right? And records all the things that are being done in the application, all the methods, all the classes being invoked as something happens in the application. And based on what Jacoco records, it creates the coverage report. But you can connect to that agent. You can make a TCP call and, for instance, tell the agent to do something. Like, for instance, tell Jacoco to dump the current coverage information. And Jacoco will dump that information in a binary file with exec extension. And later you can use that binary file with all the classes that you have in your code base to generate a CSV file. And this CSV file will contain like multiple lines of information. Basically, you will have all the classes that are out there in your code base, and whether those classes were touched while something happened in your application or not. And this is what Jacoco uses to generate test coverage report. So given we knew that, we read the documentation and found out how Jacoco works and how we can leverage the fact that you can tell Jacoco to dump coverage information. We started implementing a solution that would allow us to generate a similar database that we used to have with Clover, but not waste that much time generating it. So how does the solution work? There are two parts to it. The first one is related to the master, right, to the main line. Every once in a while, like every hour or so, we are running all the tests that we have, right? And we run those tests in batches. And what happens in every single batch? You basically start the application and you start running a set of tests, like suite of tests against this application. We connect to that application Jacoco agent. So every time something happens in application, like some kind of test does some stuff in the application, Jacoco agent records what is happening. And that information is stored in Jacoco memory. And we also have a JUnit test rule that tells Jacoco that when tests finished, please dump the current coverage information that you have. So this basically means that for every single test that we run on a batch, we have a binary coverage information for that test. So later, when after we run all the tests and generate those binary information with code coverage, we run those for every single test. We run those files through a library that we implemented that basically takes all the binary information, matches classes that we have in our code base, and generates like 50 or 60,000 CSV files. And every single CSV file contains like human readable coverage information for every single test that we have. And what we do with these CSV files, we push them to a service that we implemented. Like this is like cloud service that we called TIMI, because it stands from the three first letters of test impact map, right? So we have a map of tests to code that those tests cover. And this map is stored in cloud. And as I said, this is the first part of the solution. The second part is basically what happens on branch. So whenever, on a feature branch, whenever a developer does something on feature branch, like makes a change to the feature branch, we first try to understand what really changed, like what files changed. Are there new files? Were some files updated, etc.? And once we have a list of files that change, we send that list to TIMI, to the test impact map service, for it to find all the tests that need to be run for given files. And it basically returns all the tests with their types, and we are running only those tests on branch, right? So this is the process, the test impact analysis process, right? Finding what changed, querying a database with information of tests to production code, and running only the tests that are relevant for a change. Okay, so once we had solution, we had to deliver it, and it wasn't that easy, because as I said, like there are 100 people working on our CI, like depending on our CI. If something breaks on a CI, it's a big pain. Like so basically this means that we are treating CI as production. We are treating everything that happens on CI, the whole infrastructure that is involved in our CI, as it would be a production infrastructure. And we are treating developers as our customers. So we had to first do some kind of acceptance tests, right? Because we know that, like, when it comes to whether the solution works or not, we knew that it works. Like, we knew that we can request TIMI to get our some tests. We were able to run those tests, etc. But we still weren't sure we are getting all the tests that need to be run, right? Like this was something that we weren't quite sure, and we had to test it. And how we did that? Like whenever there was whenever tests were run on feature branch, we were doing something in shadow. Like we were trying to find out what changed on that feature branch, particular feature branch, what files changed, and ask TIMI for all the tests that need to be run. So basically, we still were running all the tests, but on the same time, we were in the shadows trying to find out what tests we would run in the optimized way. And if we spotted that some tests failed, we tried to find whether this test was returned from TIMI. Because if it wouldn't, then we would lose like very valuable information. Like this test wouldn't be run anymore, so it wouldn't fail, and probably would cause problems on production. And once we soaked that our solution for like 3 weeks or so, we determined that every time something breaks normally on the feature branches, it would also fail with Timmy. So we said, okay, let's give it a try. Let's roll it out to our feature branches. Let's roll it out to production. But before we did that, it's not only, it's not good enough to confirm that the thing works as it expected, because you also need to confirm that it's reliable, right? So the service that we were using had to be operational all the time, like 99.9% of the time. We're basically using all the same KPIs for our internal services that operate on pipeline as we do for like production services. So that meant that we had to like build our operational skills. We had to invest time into logging metrics, building dashboards that would tell us what is the current availability of our service, of the Timmy service. Does it respond in a timely fashion? Like, is developer receiving a response within 500 milliseconds? And with all the tests that need to be run on a feature branch, and we basically like created dashboards like that. Of course, there were like different layers of those dashboards, like the distribution of response times. We had to find out how will Timmy work when there is like a spike of requests, when, for instance, there are I don't know, 70 branches run at the same time, and 70 branches ask Timmy for coverage or tests that need to be run. And we also had to understand like what is the impact on the database that Timmy is using. Like, for instance, what is happening to the database when Timmy is first creating the map of tests to production, and what will happen if during that creation some feature branch will ask Timmy for tests that need to be run. Will we see some kind of problems there when it comes to database? And once we created dashboards and started monitoring and confirming that it seems like it works and it's operational 99.9% of time and responds well, even in those stress scenarios, it still wasn't quite enough, because it's not good enough to just start creating metrics, had a dashboard, and that's it. Like, you still need someone to look at that dashboard, right? And my experience is that people tend to overlook information that they see on dashboards. Like, maybe they don't want to address the problem. Maybe they know that if they look into the problem, it will take them a lot of time to investigate the root cause, etc., etc. So we had to put some kind of automation in place, so that it will replace a person and person spotting a problem with how Timmy operates. Fortunately, we have systems for that. Like, we can, for instance, every single second generate a mock request to Timmy to get us all the tests that need to be run. We can also check whether Timmy contains a test impact map that we expect, etc. And this is what we started doing. Like, we started basically continuously monitoring the service in our production. And if anything would be wrong, would go wrong, and like, for instance, the response times would increase from 1500 milliseconds to 2 seconds or something like that, or the test map would not contain as many records as we expect, we would be notified. And that would be done by automated system. We use PagerDuty for that purpose. So basically, if something goes wrong, you are getting SMS saying, the service that you implemented doesn't work, and it's potentially affecting developers that depend on your CI. Fortunately, we don't have any incidents right now, and we've been lucky for the past 6 months. We didn't have any kind of incidents, so developers were not impacted by the fact that we were having a service that tried to optimize test runs. Okay, so you've seen. I mean, I explained to you like what was the problem that we were trying to solve, what kind of solution we decided to to do, and how we delivered it to our production, to CI. Now the outcomes, like were we successful? And what you see here is a dashboard that we usually use to find out how much time we are saving with test impact analysis. At the top, you have like the number of branches that were affected by test impact analysis, and this is information for 5 working days. So during those 5 working days, we had 340 feature branches that asked the TME service to get like optimized minimal set of tests that need to be run. And in the bottom, you have the numbers that you are most interested in. The first number, like 31%, is the number of tests that were saved. So basically, usually we would run 100% of tests, but now we are running only 69% of tests on average. And the number 29% tells you how much time TME or the test impact analysis helped to save. And it was like, for the past week, it was like not 29%. So we didn't, we no longer spent 45 minutes running tests. We spent only 30 minutes, right? And we are still working out how to improve that number, because there are cases where we decide to run all the tests. Like for instance, when you are changing a POM XML file, we aren't really sure what needs to be run, like what types of tests need to be run. We need to like go very safe there and tell, let's run all the tests, because we just don't know. Or for instance, when we are changing some kind of XMLs, other XMLs, or some kind of SQLs where, for instance, we keep test data. We still don't know how that test data is linked to tests that we have. So sometimes we need to run all the tests. But there are ways to optimize that, and we are probably going to work on that and even improve the numbers. But basically now, instead of running tests for 45 minutes on feature branches, we spend only 30 minutes running them. So like, yeah, this is the benefit that we got from test impact analysis. We still run all the tests on master. So this is what you see here. And the reason is that we haven't finished like monitoring how whether this optimization works. So every time something breaks on master, we are going back to the test impact analysis, trying to find out, was this test run on feature branch or was it skipped? Because if it was skipped, this is a case against test impact analysis, and this is a case against introducing it to master. So we are still in the process of monitoring that, but yeah, I mean, we are getting more and more confident that it just simply works. So probably in a month or 2, we are going to enable it also for master. Okay, the takeaways that I want you to take from this presentation, basically. So the first thing that wasn't quite obvious from that presentation is think about your growth plan for automated tests. Because the whole reason that we had to do that was that we didn't have a growth plan. We didn't anticipate like those huge numbers of tests. Like we didn't thought what is going to happen, like what should be changed when we reach, for instance, 5,000 integration tests, or we reach 100 system tests. Like, should we keep adding tests, or maybe we should start optimizing things? Maybe we should like review what we have, and maybe we even put some kind of hard limits on how many tests we have and how much time it takes to execute those tests. In fact, we are in the process of introducing such limits. Basically, you have a budget of test execution time, and you need to decide what you are going to run, what tests you are going to run within the budget. So think about like how you are going to react, what you are going to do if your automated tests grow to huge numbers. Like if you right now have like, I don't know, like 1,000 tests, think what is going to happen if you will have 100,000 tests. Like how your execution time will change, like and what kind of problems it will cause, and who will be affected by those problems, because it's gonna happen, but you will just need to wait some time for it. And you don't want to be in a situation where you need to react quickly, so just get prepared. The other takeaway is that it's really not that hard to introduce test impact analysis. I walked you from the solution that we did, and this solution required some implementation, right? We had to implement a service from scratch. We had to implement like some kind of scripts that would talk to Jacoco, etc. But this was because like the number of lines of code that we have and the scale of the code base is so huge that we couldn't use anything that is on the market. And if you look into Clover and look into Clover documentation, you will find out that Clover allows you to optimize tests. Like based on the code coverage information it gathers, it can decide what tests need to be run for a given change. So just try, experiment with Clover, see if it works for your code base, and see if you can benefit from it. Yeah, and the third thing is that treat your pipeline or treat your CI and CD as production. At least try to look at it as production. If you have some kind of KPIs for production, try to also do those KPIs and meet those KPIs for pipeline. Not only because like we care about development and we care about developers, and the thing is that in my company, developers are responsible for implementing automated tests, right? So if something goes wrong with automated tests, for instance, they take longer to run, it's changing their approach to implementing more automated tests, right? Because they are now hesitant. Like, I don't want to implement yet another automated test because this will mean that instead of 45 minutes, I will need to wait 50 minutes for feedback. But if you are going to change like how much time it spends to run automated tests, maybe you will also change people's minds, right? And how they what they think about automation. But the other thing is that your pipeline is a part of production in CI/CD. Like if you work in continuous deployment, every single change will go through that pipeline. So if there is something that is taking a lot of time, like for instance, test execution, and it's taking a lot of time, this basically translates into real customer pain. Because there will be problems on production. The question now is how fast you can fix those problems. And if you need to spend 45 minutes running tests for a fix that is causing pain, like a number of customers, like they won't be happy that we are just proving that the fix is working correctly. We need to be more agile when it comes to doing the tests. Yeah, and this is basically the presentation. Thank you.